Good morning, students. Once again, welcome to the statistics class. We'll continue the problems of binomial distribution in this video, how to fit a binomial distribution. I've been solving problems from the second PUC Karnataka State Syllabus Statistics textbook. I have solved the problem exercise, unsolved exercises, 35th and the 36th problem in the previous video. Now today I will be solving you the 37th and the 38th problem. Okay, whoever is interested can go through it, and this is the problem, that is the 37th problem. I'm going to solve it. It says that assuming that birth to male child and birth to female child to be equiprobable, find the probability that a family with 3 children has 2 or more male children. Assuming that birth to male child and birth to female child to be equiprobable, find the probability that a family with 3 children has 2 or more male children. Again, when we go to this question, nowhere they have mentioned about binomial distribution. And again, a question comes, how can we consider this as a binomial distribution problem? Okay, it's a simple one. This is all about a child. They are speaking about a child. A child can be a male child or a female child. That has two outcomes. A child can be either a male child or a female child. So they are speaking all about the male. That means they are considered, if there is a male child, it is a success. If it is a female child, it is a failure. That is what they considered it as an experiment. So success or a failure kind of an experiment, and they are doing it for how many children in a family of 3 children. So this is how you can consider this to be as a binomial distribution. Okay, so what it is all about? It is all about, for them, the male children. So I'll write denote X as the number of male children. The number of male children. Okay, number of male children in a family of three. Of three. Okay, so they are testing in n is equal to 3. Next, then what is P? If it is a binomial distribution, we should have P. What is P? They have not given anywhere that number P, but they said very simple, assume that birth to male child, birth to female child to be equiprobable. Equiprobable means it is 0.5. For probability for a male child will be half, and probability for female child will also be half. Okay, exactly 50% chance, equiprobable. So P is 0.5, Q also will be 0.5. Then it's PMF, students, it's PMF. And I do it writing it directly by using those values, students. It would be 3CX 0.5 raised to X 0.5 raised to 3 minus x, where x has the range 0, 1, 2, 3. Is that okay? Now, they said find the probability that a family with 3 children has 2 or more male children. 2 or more male children. 2 or more male children. It is the same, students. How do we express 2 or more? It is x greater than or equal to 2. So if it is x greater than or equal to 2, they're asking us to find out P of 2 and P of 3. Is it right? P of 2 or P of 3. So it will be like this. Let us take this. 3C2 0.5 raised to 2, 0.5 raised to 3 minus 2 plus 3C3 0.5 raised to 3, 0.5 raised to 3 minus 3. 3C2 is 3, students. Okay, 3C2 is 3. 0.5 raised to 2 is 0.25 and 0.5 raised to 1 is 0.5 plus 3C3 is 1. 0.5 raised to 3 is 0.5 raised to 3 is 0.125. Is that okay? 0.5 into 0.5 into 0.5. It is 0.5 into 0.5 into 0.5. It is 0.125 into 1. So if you simplify this, 3 into 0.25 and all 3 into 0.25 into point into 0.3 into 0.25 into 0.5 is 0.375 and this would be 0.0125, and when we add this we get the answer as 0.5. So the probability of 2 or more children is 0.5, and that's what I think is the answer. If you see it here, see our answer is 0.5. Okay, right. This is the problem. This is the 37th problem. Now when we consider the 38th problem, students, the 38th problem, right, this is also a kind of a problem which we can solve it easily. So I wanted you to understand this, students. Read the question, make sure that you are reading the question twice so that you can understand exactly what's going on. Okay, shall we start? See it. The probability of an arrow hitting a tree is 1 by 3. If 4 arrows are aimed at the tree, find the probability that 3 arrows miss the tree, or at least 2 arrows hit the tree. Again, we see in this question also, we don't see any word called binomial word. So what is this all about? It's all about an arrow being shot. Okay, so it has two outcomes. Either it may hit or it may not hit. Is it right? Two outcomes. If it hits, it's a success. If it not hits, it's a failure. Success or a failure, like that. They are considering for how many arrows they have shot. They have 4 arrows. So success or a failure experiment, doing it 4 times. So on that basis, we start with this. X denotes the number of arrows hitting the tree. Number of arrows hitting the tree. So, how many arrows they have shot? 4 arrows. And the chance of hitting a tree is given to us as 1 by 3. When P is 1 by 3, Q will be 2 by 3. Correct? Fine. So now, it's PMF as it is. It's PMF. P of X is equal to 4CX. P is 0.33. Consider it as 0.33 raised to X. And this you consider as 0.67 raised to 4 minus x, where x has a range 0, 1, 2, 3, 4. 4 arrows dropped on it. So the first probability they asked is, students, probability of 3 arrows miss the tree. 3 arrows miss the tree. When they say 3 arrows miss the tree out of 4, then how many arrows might have hit the tree? 1 arrow might have hit the tree. So I can write 3 arrows miss the tree is equal to 1 arrow hit the tree. 1 arrow hit the tree. Okay. So that is equal to P of 1. So that is equal to 4C1, 0.33 raised to 1 and 0.67 raised to 4 minus 1. Okay. 4C1 is 4 students into 0.33 raised to 1 is 0.33 into 0.67 raised to 4 minus 1 is taken as 4.67 3 times. 0.67 into 0.67 into 0.67 is 0.0.3007. So we take this as 4 into 0.33 into 0.3007 is equal to, we get the answer as 0.3969. This is the probability of 3 arrows miss the tree. The second one, students, what is the second one? The second one they said is at least 2 arrows hit the tree. At least 2 arrows hit the tree. Probability at least 2 arrows hit the tree. Correct? So that is, again, at least word comes, I can say it as 2 or more. 2 or more. So it would be probability x greater than or equal to 2. So when you know the range is 0, 1, 2, 3, 4. So it is 2 or more means it is probability of 2 or probability of 3 or probability of 4. Rather we can, it is 3 probabilities you have to find out. Rather we can take the complement of this, that is equal to 1 minus probability of 0 plus probability of 1. We can consider this, students. So it is 1 minus P of 0 is what? Okay, what is this P of 0? P of 0 is 4C0, 0.33 raised to 0, 0.67 raised to 4 minus 0. This is P of 0. Okay, consider this as the flower bracket inside. Then plus, again one more, 4C1, 0.33 raised to 1, and then 0.67 raised to 4 minus 1. So it would be like this, 1 minus, okay, 4C0. 4C0 is 1. 0.33 raised to 0 is also 1. And 0.67 4 times. 0.67 4 times. 0.67 into 0.67 into 0.67 into 0.67 is 0.2015. 0.2015. This is 1 plus 4C1 is 4. 0.33 raised to 1 is 0.33 and 0.67 as we have known here is we have got it as 0.3007. So this is equal to 1 minus 0.2015 plus, when we take the product of all these three, we get 0.3969. So it is 1 minus 0.2015 plus 0.3969 is 0.5954. And last, 1 minus 0.5954 is equal to 0.4046. So this is the answer that we get. for this problem, which is all about the arrows, students. 0.4046. I hope you have understood. Okay, so in the next class, we consider some other problems. Thank you.